All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing yet another one of the quiet streams, which is fine because today I'm hoping that we get to at least an hour and a half, even though it's one of the quieter streams. I want it to be at least, you know, as long as my usual streams. Um, but yeah. So, what have I been up to? Um, Between yesterday and today, I'm trying to remember what all I did because there were a couple of things that I was looking into. I did have conversations with Gemini. Actually, okay, there were a couple of conversations that I had um that were Git related and a couple of other things as well. One of the other things was I was trying to discuss with Gemini what the process would look like. Actually, no, I already know what the process would look like. What else did I do? Sorry, I'm just trying to recall what exactly. So, okay, yeah, I just remembered. Sorry. Yesterday, I logged back into my Ubuntu installation on this machine, the machine from which I'm streaming to Twitch, because I have Windows and Ubuntu running in dual boot. So um, dual boot as in like one at a time. So right now I'm on Windows, and usually after I'm done streaming, I pretty much only log into Windows to stream because I haven't managed to uh, completely move my streaming setup over to the Ubuntu side yet. But yesterday I wanted to try and do exactly that because I've made progress. I've moved. I created a Linux build of my VTuber app. After I ran it on Ubuntu on my laptop that has an NVIDIA GPU, I noticed. Oh, also I had to pass it the flags because on Ubuntu, if you want an application to your use your discrete GPU, then you have to pass it some flags. There are ways to automate that process, but I haven't done that. So anytime I want an application to use the discrete GPU, which is the NVIDIA GPU, I have to pass those flags, and then it's going to use the GPU. And I can also see in BTOP whether the GPU is being used. And because of this, I became aware of a problem. Apparently, at least on the Linux side, the GPU um, ends up in a state where it is just giving all of its power to the application, meaning the application can and will use 100% of the GPU's power um, if it's given the opportunity to words, holy shit, if it's given the opportunity to do so. So what would end up happening is because I hadn't capped the frame rate on in the application, so it was running at whatever frame rate it could, which was like a pretty high frame rate. As a result of that, whenever I would look in BTOP, I would be seeing 100% GPU usage, and then the GPU would start to heat up pretty quickly. 100% GPU usage is not, it's not good. And it's definitely not good for an application that is uh, just just my VTuber avatar. For something so lightweight, 100% GPU usage is just no. Um, So one way to get rid of that would have been to cap it on the Unity side. I don't remember if I did actually try that or not. I can't remember. Instead, what I did, well, I mean, okay, I'm saying instead because I can't remember if I did actually try it on Unity or not, like within Unity, changing some settings. I don't know if I tried that. I can't remember. However, what I did do is install this application called Mango Hood, or Mango HUD, I should say, Mango HUD. Let me open this up so I can give you like a proper description of what this application is. Uh, just a second. Mango HUD, a Vulkan and OpenGL overlay. So there's a bunch of different things that you can do with this application. One of them is FPS limiting, so you can limit the frame rate of whatever application you're running. You basically launch your application through this application, so it becomes a sort of layer in between your application and I'm trying to remember if it's between your application and the OS. I guess in a way, yeah, it's a layer between your application and the OS, and that's why it's able to do a couple of these, actually a lot of these extra things. I want to give you. Oh yeah, it says it's a Vulkan and OpenGL overlay for monitoring FPS, temperatures, CPU/GPU load, and more. And there's a bunch of things it can do, including um, limiting FPS, and that's exactly what I wanted. And I believe my application is running on Vulkan because I had to pass in a specific flag that mainly only works on Vulkan apps, not on OpenGL apps, and that's when the FPS limiting was working. But yeah, anyways, going back to what I was talking about with my streaming setup on Ubuntu, one of the things I had to take care of was this, the VTubing app running on Ubuntu. So I exported it, ran it in Ubuntu. I ran into that issue of 100% GPU usage. So I then ran it through Mango HUD, and now it's great. Now it only uses like maybe um, I don't know, 30 to 50% of the GPU, even less. It's like it fluctuates. The highest would be 50%, if that at all. So that's great. Okay, that's the VTuber app side. Then we have these three things that we see on the screen. The matrix rain, the hold on, is it running? Yeah, it is. So the matrix rain and the two tmux windows in the bottom right and top right, these three things are running within one WesTerm tab. So all I had to do was just open up one WesTerm instance, and then I would have a tab. I split that tab into three panes. Um, and then one went for the matrix rain, and the other two I basically SSH'd uh, into my machine where the tmux sessions are running, and then I set that up. So basically what you're seeing on the screen right now, I was able to set this up natively, or rather on the Windows machine right now, what you're seeing is the RTMP feed, but on the Linux machine, or sorry, wait, on Windows, I'm not going to say on the Windows machine, on this machine, on Windows right now, what you're seeing is the RTMP feed, which is being captured from another machine. But when I'm running Ubuntu on this machine, I was able to set it up so one WesTerm instance running on Ubuntu on this machine, no RTMP feed involved. One WesTerm instance running on this machine was able to display exactly this, which is the matrix rain and the two tmux sessions, which is great. So that thing is handled. The next thing I had to take care of is the browser, which you see in the bottom left. That also I got it handled. It's being captured. So all of that is done. One issue that I ran into, actually, okay, bonus, additionally, the webcam, I don't want to connect it to this laptop. I have it already connected, and That's how we get the webcam feed over RTMP. So instead of connecting the webcam directly to this machine, I figured I would stick with the RTMP feed, and then the webcam feed is going to be the only thing that is being sent over the RTMP feed. Everything else is going to be running within the Ubuntu instance itself. And guess what? Even that, amazing, great performance. There is still that 1-2 second latency, but other than that, we are good. The only problem I'm running into now is all of this stuff together, it gives a not so great frame rate. So the VTuber app, its frame rate starts to go down, and that kind of bogs down the frame rate of the the OBS capture itself. By the way, yeah, I was able to run OBS as well and start a capture and you know, set up all of that stuff and get a recording going. And I noticed that everything else works fine, even having the RTMP feed running. It works fine. It works great. The only time I run into a problem is when the VTuber application is open. That's the only thing that seems to be eating up eating up frame rate. So I think it's time for me to start rushing with building, at the very least, a placeholder VTuber application, a placeholder terminal based. I should specify that, a placeholder terminal based VTuber application. I think it's time that I started spending time building one of those, and I'll get something set up really quick. I have no idea like what I want to do, how I want to go about this. I have some ideas like, okay, I know that I want to use Noise RS to generate a bunch of designs and stuff. I know that I want to use, I believe it was DASP. I don't remember exactly. There was a digital signal processing crate. I don't remember if it was DASP or Fun DSP that I was going to use to create audio reactive effects. So basically, my plan is to create shapes and stuff using Tiny Skia, which also I was going to mention that later. But yeah, I'm going to create shapes and designs using Tiny Skia. I'm going to create patterns, and probably even shapes using Noise RS, and the parameters for all of these can then be animated using using the signals that DASP is going to help me capture. Basically, it's going to be animated using my vocal data, my vocal audio data. And then all of this is going to be rendered out into a pixel buffer. And then that buffer, I have to write a compatibility layer, not a compatibility layer, but more of like a translation layer to display it onto a Ratatouille window. Now, because so far I'm not that great with Ratatouille, I think I'm going to take Gemini's help to sort of vibe code something that's literally just a blank screen, that that reads this pixel buffer and translates it into something that can be printed, like, you know, directly onto the screen. Who knows? Maybe it might not even be something very complex. Maybe I can, um, because I'm doing it bare bones right now. I'm not making it very complicated with, you know, a bunch of widgets and a bunch of UI here and there. Maybe things might end up being a bit simpler. Actually, let me try asking Gemini a question about it. Because okay, Tiny Skia, Noise RS, and DASP. For these three, I'm going to be doing my own research, doing my own work. I'm going to be learning about them. I'll take a little bit of help from Gemini as well to, you know, understand the API and understand the various possibilities and stuff. And with something like Tiny Skia, I think I definitely need the help of an LLM because there isn't ample documentation for it. Because Tiny Skia is based on um, I forgot what the other framework is called. It's a much bigger framework meant for web development stuff, I believe. Okay, it's called Skia. It's a 2D graphics library. And I don't remember what the language is, so it's written in C++. Um, okay, yeah, it's written in C++. Now, I'm using Rust. Tiny Skia is a small subset of the drawing functions that Skia has. It's not the full Skia engine. It's just a tiny subset of features which have been written for Rust, and I believe they're specifically for CPU rendering, not for GPU rendering, which is exactly what I was looking for. CPU rendering. I'm trying not to push this to the GPU. I could look into pushing it to the GPU at a later time if I see a benefit there, because the end result of this is supposed to come to the end result of this is supposed to go to a terminal, and it's supposed to be quote unquote rasterized in a terminal. So I don't know how much benefit I'm gonna see from moving that workload over to the GPU, because again, it's not drawing onto like a GUI window or something like that. The data I'm after it has been rendered. I'm not going to be It's not going to be rasterized and printed onto a GUI window. It's going to be after the rendering, when I have the pixel values, I'm then going to be translating it into something that would work for my terminal window. More specifically, something that would work for Ratatouille. What was I talking about? I forgot what I was talking about. So I'm gonna move over to I'm gonna continue with this question that I was gonna ask Gemini. Um, Give me a second here. I made a mistake. Okay, all right. Hey, so I have a project in mind where I'm gonna be using. Let me mention Rust. A Rust TUI project in mind, where I'm going to be using tiny Skia to draw and render shapes into a buffer, and then I will write a translation layer to convert that data into something that can be displayed in in a terminal window using Ratatouille. Um, I can handle the translation layer and tiny Skia drawing and rendering part, but I don't know much about Ratatouille, so I would like your help with that. Nothing nothing complex, mainly just a Ratatouille window that displays the contents of a buffer. How do I approach this? All right. Since you already have the heavy lifting covered, tiny skier for rendering to a pixel buffer and your own translation logic, your approach to Ratatouille can remain beautifully straightforward. Because Ratatouille operates as an immediate mode UI framework, you don't need to spin up a complex what? You don't need to spin up complex state components or widgets. Every time the screen refreshes, you simply feed your pre-calculated grid of characters and colors directly into Ratatouille's draw loop. The cleanest, most performant way to handle this is by implementing Ratatouille's widget trait on a custom struct that holds your translated buffer data. Project architecture. The loop typically behaves like this every frame. Uh, Tiny Skier draws shapes onto a raw array of unsigned bytes, which is the pixel buffer, and that's going to be either RGBA or BGRA. Then you have your translation layer. This reads pixels and processes them into a grid of characters, foreground colors, and background colors. Okay, all right. And then Ratatouille renders that translated grid to a terminal screen inside a custom widget. Okay, implementing a custom widget. Instead of messing around with Ratatouille's high-level canvas, which is designed for drawing shapes inside the terminal using floating point math, you should write directly to Ratatouille's low-level buffer. Here's a template of how your custom widget should look. Okay, I'm gonna copy and paste this code so we can take a look at it here. This is good. So we can look at it here. I will create um, some O3 and save it and paste. So this is the Rust code. Okay, there is actually, let's look at this with some syntax highlighting. Where are we? Some repo O2. Yeah, okay. Let's do bat sum O3. Damn, there's no syntax highlighting. How do I get syntax highlighting here? Actually, wait. I have pasted some Rust code into a file, but I haven't actually. If I wait, let's make a copy of this. Let's copy this to this, and now let's try this. There you go. Okay. So now I don't need to specify the, what do you call it? Um, the syntax highlighting thing. Anyways, okay. So we have our using statements first. Then we have a struct for terminal cell, a single cell in your translated buffer. Okay. Then we have Skia frame widget, the custom widget that holds your translated frame. Okay. All right. Then within this widget, we implement the render function. Okay, all right. So there is another thing as well, right? Tiny Skia is going to be rendering to a specific sized grid. My translation layer is going to also need to be able to um, set the size, or how do I say this? Resample, essentially. It's going to need to be able to filter or resample that specific size to the size that I'm trying to render it to, or to the size of the grid that I'm trying to render it to. Just to give an example, imagine you have an image that is, I don't know, 400 by 600 and you want to render this to a 1920 by 1080 grid. You can't do like a one-to-one pixel thing because, they're different sizes. And this is where you have to apply some sort of filtering method. So I guess we'll get to learn about that as well. We're going to be applying filtering methods. I'm also going to need to apply some sort of diffing mechanism. And I only know about this diffing mechanism thanks to learning about how Ratatouille does stuff, because Ratatouille apparently has this thing, and this is one of the reasons why it tends to be a lot faster, is that it only draws the changes and stores like changes. It doesn't like replace entire pixel buffers. So like it's not taking the entire image and changing the entire thing. It's just changing the specific differences that need to be changed. And I feel like if I implemented something like that, it would definitely be helpful. It would definitely be helpful. I might need to start offloading these things to a different thread. Yeah, I might need to do that. I'm not sure how I want to set up that kind of thing. But I mean, that is assuming the application even needs multi-threading. It's probably going to need async at the very least. It's probably going to need async. So maybe I might need to, bring Tokyo in here and do stuff using Tokyo. Um, but yeah, I'll have to see how to go about that. But this should be exciting. This should be very interesting. There's going to be a lot for me to explore here, and with my admittedly very basic, still very basic, what do you call it, Rust knowledge, I'm going to be building what I can. And also, with the help of Gemini, I'm going to be building whatever I can. So Gemini has given its own suggestion for what the code should look like. Hold on. Oh, it's just stuck. Yeah, Gemini has given its own suggestion for what the render code for the widget should look like. There might be some more information here as well. Okay, so there's the information about the canvas, and then there's about hooking it into the Ratatouille event loop. So that's going to be another separate thing. So I'm going to copy that and paste it into. I don't want to. I don't want to make this a. I don't want to fire up the Rust. Wait, okay. I've pasted some Rust code into a file, but I haven't set the file extension to be an RS file. I've done this on purpose. I want to read this file using bat rust, but because bat know doesn't know it's rust, so there's no syntax highlighting. How do I fix that? You can tell bat exactly how to highlight this by using L or language. This forces bat to treat the file as a specific language, completely ignoring the missing file extension. Okay, all right. Um, so let's first get rid of this file. Then we're going to try and run this, passing L. Actually, L comes here first. L rust. Okay, we got that. Um, dude, I love Zoxide, dude. Holy shit, it is so useful. Okay, bat sum04 l rust. Okay, this is our main event loop, our main Rust file. So we can see first clear is being called, clears the terminal screen. Okay, then we have the loop. Within the loop, we are doing terminal draw, and I guess that's a closure. Yeah. Okay. F dot render widget, and I'm guessing once we pass this widget, something else ends up calling this render function for the widget. And there's also the chunks that we are passing in. The chunks, I'm assuming, is the wait. Oh, chunks is I thought chunks is the data. Chunks is not the data. We are passing the data into the widget when we create the instance of the Skia frame widget struct. When we create the instance of that, we pass the data into cells. So loop is going to be our main thing that we are, doing everything in. Any tiny Skia drawing stuff that needs to be done, that would also be done within this loop. So each time we draw something using tiny Skia, render it out, and then pass it to the widget. Well, sorry, render it out, translate it, and then pass that translated data to the widget so it can be drawn to the screen. And because this is one widget that I want displayed on the screen, so far, I'm not complicating it with any other extra information. So I think we should be good. I think we should be good. This is going to be where we're going to be doing our main work. And yeah, yeah. Once I've set up the animation stuff for this, then I would like to also set up the digital signal processing, basically the audio reactive features. I would like to set that up as well. There was a very simple way to set that up. I can't remember exactly what it was, but yeah, once I've got like a base animation going here, then I'll also set up some audio reactive capabilities, and let's see where to go from there. Dude, once I've developed that, I believe we will be ready to pretty much start streaming from Ubuntu. Yeah. Once we have done that, I'm pretty sure we will be ready to start streaming from Ubuntu because everything else is done. The the I mean the whole idea with this app that I'm making is to replace the VTuber. Well, the whole idea with the app that we are currently discussing right now is to replace the current VTuber app that I'm using and replace it with a terminal based application. So if we are able to accomplish that, then we are going to take a load off of the GPU, which is amazing. Um, I won't really be using the GPU at all at that point. Yeah, I don't think I'll be using the GPU at all. I did try this thing of trying to run various applications through the GPU. It just didn't work out that well. Even OBS, trying to run the application off of the GPU, hoping that, the video capture and stuff would be better if I tried to use um I forgot what the other one was called. I think it's called Pipewire. The one I'm using right now is X Composite. The other one is called Pipewire. I was hoping I would be able to use that, but then Actually, that doesn't even necessarily have to do with, a discrete or internal GPU. It's it's just two different protocols. Um, I stuck with X Composite because my system is old enough that Ubuntu decided to use the X11 windowing system instead of Wayland. So, um, what was I saying? Yeah. Anyways, um, once I've set that up, I think we'll be ready to move the entire setup over to Linux. I don't think there's anything else really stopping me at that point from streaming, directly from Linux to Twitch, from Ubuntu to Twitch. And we won't even be having, this is a huge bonus, by the way, of moving it over to Ubuntu. We won't have any more of the latency with, um, with any terminal related stuff. So, I mean, the matrix rain, you can't really see latency anyways. Like the latency won't really mean anything to you because all you're seeing is the matrix rain. All I'm seeing is the matrix rain, right? When when the thing starts and when it stops, you don't have any reference for that. So you don't see any latency there, which is great. That's amazing, right? Where you do see latency is with the other two windows. The other two windows are tmux sessions. And if I move, so like, for example, I'm moving up 3 lines now. One, two, three. Watch when it happens. There you go. So it's like at the very least a 1 to 2 second latency, if not more. So we won't be having that issue anymore, which is great. That's awesome. We will have latency in the webcam feed, but I'm okay with that. Um, it's just a webcam feed, so a little bit of latency there, I don't mind that. At some point later, we can look into if there's any way to improve the latency, but for the most part, I think I'm good. Um, I'm good with the latency for the webcam as long as everything else doesn't have any latency. And also, just streaming off of Ubuntu in general, we are okay for the most part. At the very least, for the 1.5 hours that I do stream, I think the system can hold out for that long. I think we'll be okay for at least that long. Um, I might need to introduce a sort of cooling solution. I mean, I have like those what do you call it? Those you get those like laptop cooling fans, external cooling fans that are designed as like to be a sort of pad, and they come, sometimes they come with legs that you can fold out, and then that becomes the words, holy shit, that becomes the surface. Wow, why was that so hard to say? That becomes the surface on which the laptop is kept. Well, what I did is I took a small fruit crate, a plastic fruit crate, and those things usually, they're made of mesh, and there's like a structure holding them together. But for the most part, they're like mesh. They're plastic mesh kind of thing. All I did was tie the fan, or that fan, contraption thing. I just tied that to the the crate, and I flipped the crate upside down, and then that became a base to keep my laptop on. And because I had tied the fan to the crate, and the laptop is kept on the crate, so now the fans are directly cooling the laptop. I don't always have it plugged in though. I need to set up something to facilitate that. But other than that, for the most part, I could very easily switch that on while I'm streaming, and it should help with cooling a little bit. let's see how that goes. I also need to see if that's going to pick up any sort of disturbance, or if the mic is going to pick up any sort of disturbance from those fans. If it's not too bad, then I can have the fan running for however long I'm streaming. And I mean, like I said, my streams aren't usually more than an hour and a half. Maybe they might go up to 2 hours or 2.5 hours, but for the most part, it's between an hour and a half to 2.5 hours. It's not anything more than that. So I think we should be fine. Yeah, dude, I'm excited to try this out. I'm excited to play around with this. For now, we're gonna have like a very bare bones application. And then once I've had the chance to, what am I trying to say? Once I get some more time, because I'm quite frankly way too busy with all of the other stuff that I'm supposed to be doing. There's a whole bunch of things in my backlog. There's the ESP32 stuff. There's also analog electronics. There's learning Rust, continuing to learn Rust, finish learning Rust, learning Tokyo, learning Ratatouille, learning deep learning. Now I've got that deep learning book that I'm going to be going through. And there's a bunch of things that I need to be working on. So I don't know at what point I'm going to actually, come back to work on the VTuber application. Who knows? I mean, once I have a established design, I might just stick with that design. Or I mean, I could change things up. Because here's the thing, right? I don't need to build like a full-fledged VTuber application. That's the amazing thing. What I need to build is specifically something that can render what I would consider my VTuber avatar, and that would be a mixture of, stuff from Noise RS and Tiny Skia. I'm gonna animate things in whatever way I can, and we'll see what I can come up with. Um, so my point with that was that I don't think I'm gonna need to, get too complicated or too complex with it. Um, for now, I can come up with a design. Later on, I can change up the design if I want. And yeah, dude, let's see how that works out. Oh, I'm gonna have to. I just realized this and remembered, actually. I just remembered this. Gemini had mentioned this, that I'm gonna need to do it in a terminal. One character is not a square; it's a rectangle usually. So one character, if I'm writing a translation layer, the translation layer is going to have to account for um, placing two adjacent pixels, um, in one character cell. So the way that we would do that on the terminal side is that the character cell will use what's called a half block character. That half block character, one half of it is the foreground color and the other half is the background color. Usually with these terminal cells, you have three properties. I mean, you probably have more properties, but the properties that we are concerned with right now are three main properties. One is the actual character itself, right? That's what's going to be rendered within this cell. Then you have the foreground. That's going to be the color of the character that's being drawn, right? Because the character is not um, occupying the entirety of the cell. It's occupying a certain percentage. Like if you write, or like, I mean, look at this. Look at what we are seeing here. If we look at the word buffer, for example, and let's look at the letter U. Uh, Wait, are you guys able to see that? I don't think you're able to see it. Oh yeah, no, no, you're able to see it. Sorry, my bad. So let's look at the letter U. Um, so this is one cell in the terminal. This cell, as you can see, it's not square. It's a rectangle. You have the letter U. That's the character that the cell is rendering. And then you have a foreground, which is the color of the character itself. So that's the color of the U. And then you have a background, which is what's meant to be the rest of the color. So if U is occupying a certain section of this cell, and that would be considered foreground, then literally everything else in that cell would be considered background. And these are the three main things that we need to control when we are writing our translation layer, when we are trying to render something to the terminal. These are the three things that we have to control in every single cell. Now, one added complexity that we have is this half character thing. It's that if we don't do that, then we're going to end up with a sort of skewed image with a weird aspect ratio. And I don't want that. I wanted to maintain a proper aspect ratio. So I'm going to be using a half block character where half of the character is the actual, or half of the cell is the actual, character, half block. And that's going to be occupied by whatever the foreground color is. The other half is considered the background. So we can control that color using the background color. And in this way, we can render 2 pixels in one terminal cell. So I'm going to have to handle the math surrounding all of that. Additionally, within all of this, I'm also going to have to implement a diffing mechanism. That should be a good learning experience for me. I wonder how quick or how slow it would be to diff these things. I need to look into if there are quicker ways to diff these things, and if at all they require to be diffed on a different thread. Because if they end up taking long enough to diff, then yeah, I might need to put it on a different thread. But the thing is, all of this has to happen really fast, right? That's the thing that's kind of concerning for me. All of this has to happen really fast. This is one frame we are talking about, right? One frame is drawn by TinySkia slash NoiseRS and then rendered by TinySkia into a pixel buffer. And then that's passed to a translation layer, which translates it to something that Ratatouille can use. And the translation layer is also going to be doing the math to put 2 pixels into one cell. And after that, sorry, zoned out. So my translation layer is going to be doing a couple of things. One, it's going to be diffing. It's going to be diffing the. You know what? I should see if I need to diff before the translation or after the translation. That's something I should look into. If I should be diffing before or after the translation. I feel like diffing after the translation is going to be very complex for me, because after the translation is done, then 2 pixels are part of one cell, and now things are going to get very complicated. I feel like diffing. I feel like diffing there is going to be very complicated. I need to diff the pixel buffers. Yes, yes, okay. So before translation, we're gonna be doing diffing. Um, Dude, I just realized the time. Holy shit. We've been yapping for like close to 50 minutes. Just just yapping about the Ratatouille VTuber application that I'm planning on making. Uh, I don't mind though. It's fine. Okay. What was I saying? Yeah. So I can each time Tiny Skier does a render, I can store the pixel buffer into some kind of temporary place. And then the next time, or well, I'll store it into another buffer called previous buffer, which is basically to say, this is the buffer, this is the data that was rendered previously. And then the next time Tiny Skier does another render, first I'll diff the two, and then the I'll pass the changes that have taken place. I'll pass those changes into the translation layer. Actually, dude, that would make things much faster, right? Yeah, I think so. I think that would make things much faster. Wouldn't it? I think so. I think that would make things much faster. But the thing is, we would still be reconstructing the entire buffer all over again. So how do we deal with that issue? Yeah, we're gonna have to figure out some math for that. Um yeah, we're gonna have to figure out some math for that because what we're gonna do is we're gonna diff the frame. We're gonna diff the previous frame with the current frame. Tiny Skia rendered frame, by the way, not Ratatouille rendered frame. We're gonna diff the two, and then we're gonna um pass it over to the translation layer. What I could do is I could store the previous translated buffer in some sort of buffer, like the previously translated frame. I could store that into some sort of buffer and only make changes to the places that have actually changed, if that makes sense. Like I'll just re I'll just draw over that buffer again and send that out. We're not gonna I have to see how to go about like drawing in specific locations in the buffer, because I feel like the fact that this is um I feel like the fact that this is a fixed sized array is probably going to give us some sort of benefit. Probably it's going to give us some sort of benefit. I'll have to do some research on that. In terms of speed, which one would be faster, and would the speed in this case actually make a difference for us or not? But yeah. Um, Once we have these locations, because like okay, when we are diffing the two, like okay, let me draw it out here. I don't even know how I'm gonna draw this out, but let's do sum O5 and save. Um, I don't think I need this file anymore because this is what we were using when we were learning about, Git Git's inner workings. I'm still learning about Git's inner workings, but this part, I'm past this. I just remembered I still have to. Ooh, dude, once we have done the Git basic stuff, I think I'm ready to set up the knowledge base at that point. Holy shit. I need to go back to that conversation that I was having with Gemini about what do you call it? The metadata that I have to add to the top. I forgot what that was called. Front matter. Front matter. That's what it was called. I need to go back to the Gemini conversation that I was having, um, where Gemini was suggesting that you could use this front matter data to store metadata, which Zola is then expecting anyways. So it's gonna pick that up. Yeah. I should. Okay. Um, Now back to this. Let's say we are talking about now. This is gonna it's going to look skewed because these are like, I'm explaining this on, you know, what do you call it? I'm explaining this on rectangular cells. So like it's not going to look like an exact square, but just, excuse that. So let's say this is for the sake of simplicity, let's make it a 4 by 4 grid. Okay, yank this, paste, paste, paste. Um, and then down here, actually paste, paste, paste as well. Okay, so these are 2 frames, okay? Okay, this is being a little bit slow, so I'm gonna do it here. So let's say we have drawn, actually, let's mention here before, no, previous, and then current. Okay, so let's say we have drawn in previously we have drawn let's say, oh yeah, let's say we've drawn a square over here previously. Okay, and now currently we want to move this square up. So what we are doing here is drawing it like this. Okay, so if you look at these two frames, you'll notice that these two cells are, wait, oh, sorry, these two cells are the same. In both of the frames, these two cells are the same. However, these two cells and these two cells are the cells that change, right? So we don't need to do anything with this data. We do need to store the positions of these two and these two, and also, what the data actually is. And after the diffing process, we are going to have this kind of information, the information telling us which specific pixels have changed. And then based on the pixels that have changed, we can pass that data over to the translation layer. And in the translation layer, we will have a previous buffer. So whatever was previously rendered by the translation layer, or whatever was previously translated, we're going to have that already sitting in a buffer. So then what we'll do is we'll take that, and in that buffer, we'll just change the specific cells that need to be changed. We're going to need to do some calculation to figure out that whole, half block, full block thing. Because again, we are squeezing 2 pixels into 1 cell. So I'll have to figure out the math surrounding that. Um, but that should be significantly faster than um, operating on the entire array, or running calculations for the entire array. Yeah, I feel like that should be significantly faster if I do it right, because this does seem very error prone. Um, it seems very error prone. And okay, if we go back to look at the logic here. So this is our widget logic. This takes in width, height, and cells. Within terminal cell, what we have is a symbol and foreground color and background color. Oh, actually, okay, I just noticed Gemini was nice enough to give examples. These are the characters I was talking about. So this is a full cell block. this is one entire terminal cell worth of block. It's occupying the entire cell. So the entire foreground color is in it's occupying the entire cell. Here you have a half block, which is a half lower block. So the foreground color is occupying the lower half of the cell, and the upper half is being occupied by the background color. So what you can do is, if you have two pixels, you can set one pixel's color to be the foreground and the other pixel's color to be the background. And just like that, you've got two pixels packed into one terminal cell. And then you have the opposite or the reverse going on in this block, where the upper half of the block is the the upper half of the cell is the foreground and the lower half is the background. Oh, then you also have this, which is entirely, just background color. Actually, I feel like I would be using all four of these. Now that I'm thinking about it, no, I will be using, not I feel like, I will be using all four of these. The math surrounding um packing two pixels into one cell, that's going to be interesting to look into. And especially once I introduce the diffing mechanism, that's going to be that's going to be very interesting to look at. I feel like we're going to have to spend some time figuring out the logic for this. Yeah, dude. We're going to have to spend a little bit of time figuring out the logic um for diffing these. We could start by figuring out the logic of just translating without diffing. Once we have the math down for just in general translation, then we can look into adding diffing capabilities to it. That would be a good way to go about it, for sure. That would be a good way. Hold on, just a second. Okay, yeah, that would definitely be a good way to go about it. And I'm trying to think of, like, okay, how are we going about this? Because, okay, when we say that, so, like, okay, hold on. How do I even explain this? Like, imagine, so these, like, okay, I keep saying like, okay, but I'm not explaining what I'm trying to say. Um, in order to have this, oh, you know what I could do? Just to have a sort of palette of these characters, let me copy them. Okay, yank, paste. Um, right. Now, let's try drawing this out. Okay, let's try drawing the current frame. See how well we are able to set that up. Um, okay, so we're gonna yank. Oh, we don't just yank that. Hold on. Um, I forgot, how do you yank one character? How do you yank one character? Okay, what if I cut? Okay, cut, paste. Is that just a space? I don't I don't know. Maybe that's just a space. I'm not sure. Oh, that's just a space. That is just a space. Okay, all right. Okay, so what I'm trying to draw here is this. I'm trying to draw the current frame, but packed into, you know, packed into a proper terminal cell kind of thing. Um, Wait, I need to ask Gemini. Hey, I'm using nvim lazy vim. Uh, how do I copy just one uh, char? Because I feel like I could use the visual mode. Oh, would that work? Oh, that would work. Okay. Okay, copying just a single character is super simple once you know the right motion. Since you are using NeoVim with LazyVim, the core Vim motions work exactly the same. Here are the two quickest ways to do it depending on where your cursor is. Method one, if your cursor is blinking right on top of the character, YL. So one character to the right. Okay, let's try that. Actually, let's try that with another. Okay, paste. Yeah, okay, all right. Okay, going back to this. So what I'm trying to draw here is, um, how do I remove this indent guides? Yeah, let's disable the indent guides. There you go. Okay, so I am drawing this, and then we add a space, and then here we will do something like this, I guess. So YL, and then paste it in the wrong place. Wait, that's interesting. It pasted in the same location though. Okay. I don't get that. Anyways, right. So this is our square, and this is much more square than actually, let me also draw out what this would look like if I didn't do the didn't do the, you know, pixel packing thing. So we're gonna have just one entire line of wait. Okay, so we can call this our one design, and the other one is going to be here. Okay, we're going to say this has the 4 characters, so 1, 2, 3, 4. Okay, then we'll have this, and we do one space, and then paste, and paste again, and then we do another space. Actually, here, another space. Right, and then we go to the next line and do another space, and paste and another space, and then here 1, 2, 3, 4. So this is what our current frame would look like if I gave each character or each pixel its own terminal cell. And in order to stop it from looking, you know, like this, all stretched, I have to pack it into one. So a 4 by 4 grid would become a 2 by 4 grid, 2 being the number of rows and 4 being the number of columns, because each character occupies, 2 pixels worth of space. Yeah, yeah. Dude, I feel like I should rush with the whole understanding of, or I feel like I need to rush with the my learning, my Rust learning stuff. I need to rush with that. To this day, I haven't had the opportunity to explore the generics system in Rust. There's some experimentation that I need to do. I haven't had the chance to do that. There's a lot of like exploration I need to do with the generics system to understand. Like, I understand the need for, the turbofish syntax. We've explored this before. We've done a bunch of turbofish related stuff. We've seen the need for it is basically just the fact that the compiler is not able to infer the type. And so you have to explicitly mention that, yeah, this is the type that we are using. And then it's able to do its thing. Um, it's not the why that I'm trying to understand. It's what makes the why happen that I'm trying to understand. The why happens because of the way that the generic system works. And what I want to do is I want to be able to trace back the the why, um, or the how of the why, I guess I should say. I want to trace that back by looking at a certain type. Because you have situations where it's like, okay, a generic type then implements a generic function. And so because you have like a bunch of you have generics going on different levels. um so that's part of the reason why you tend to have the need for explicitly mentioning types. But like, I want to get a better understanding of that whole thing. Of course, I could just do, yeah, I could just stick with just doing the turbofish syntax. It's not like, me exploring that specific thing is going to hugely impact something later on. My higher level understanding of it, my higher level understanding of the how of the why, is enough. It's the fact that, like, what I'm saying is just understanding that we need to do this because the compiler is not able to infer the type. Just understanding that is enough. So whenever we run into that kind of an issue, then we can just either use the turbofish syntax or explicitly specify the type. um but yeah, yeah. uh right. So I have a bunch of stuff to look into here. I'm really hoping that the next time I load up Gemini CLI, that is, I'm gonna have my that Gemini conversation. I don't know if it's still gonna be there because it's been a good like 2 or 3 months since I touched that convo. It's kind of crazy. I have been using Rust. That's the interesting thing, right? Even throughout, like when we were doing ESP32 stuff, we are doing it using no STD Rust, right? So I've still been using Rust. It's just one of those things where some of the higher level, or not even higher level, but some of the more features of Rust, I haven't gotten into them, and so I would like to study them properly. Stuff like iterators. I've studied them to a certain extent, and learning about them actually is very helpful. Very helpful. Because I've had situations where, for example, I had written out some logic for when I was contributing something to the Matrix Rain repo. I'd written out some logic to I don't even remember what exactly it was, but I'd written out some logic that required some sort of iteration, and um, the Rust analyzer or Clippy, one of these two, immediately gave a warning saying that this can be further shortened if you just use map. It literally gave me the line of code that I should be using instead. It was like you could um, further squash this down to just one line instead of having, you know, two or three extra lines. I think I was doing a I think I was doing a match. I don't remember exactly what it was, but yeah, that's one of the advantages of learning about iterators. There's a bunch of iterator operations that you can do within something like a map function, because within map you I believe you pass in a closure to it. Um, yeah, yeah. Now what I'm thinking is, so we've gone through. I don't need to stick with the Gemini course. I could just like open up the documentation and continue learning from there real quick. Okay, I'm gonna, because I don't want OBS to crash again, so I'm not gonna hide the browser. Instead, I'm gonna switch to BRB and just open up the Rust manual. Actually, I should open up both the Rust manual and Rust by example. Learn Rust. Okay, okay. Is Rust by example here? Rust reference. I don't see it. Okay, Rust by example. All right, I can switch back now. Okay. So in this book, I could probably increase the size of the browser. Okay, so in this book, we have all of the Rust topics covered, going from the basics all the way to much more advanced things. You can see closures being mentioned here, smart pointers, concurrency, all of that stuff. Great, awesome. I like that they've mentioned uh, writing tests much before even stuff like smart pointers and closures. We have collections here. Where's iterators? Is that up or down? That might be down. Yeah, so after smart pointers, we have fearless concurrency. Where's iterators? Um, Hold on. Understanding ownership. Okay, okay. Give me a second. Okay, writing automated tests. All right, all right. Right, I'm not able to find it, so let me. Okay, all right. It's under the same thing as closures. But where was iterator? Oh, here. And also later on. So we got done with closures already, right? We would then just need to continue from here. IO related stuff, I can also explore that. Writing automated tests, I can also explore that. I'm done with generics. Error handling is also taken care of. Collections has been taken care of. Yep, we've covered strings, hash maps, vectors. Um, Modules, I believe modules has been covered. I can't remember. And yeah, yeah. Customizing builds with release profiles. Okay, so this is the main like Rust manual book, right? There's also Rust by example, that is this book, and this gives you a very concise way of exploring Rust. So you go into the various topics. For example, um, give me a second. I'm looking for iterators, and again, I'm not able to find it. Generics, nope. Custom types, types, conversion, expressions, functions, functions, closures, examples. Where exactly was that? Oh, okay. Comes under this. That's why I wasn't able to. But are there any other iterator related? Okay, well, let me look for something else to show an example of. Let's say flow control. In flow control, we can look at if else, loop, while, so and so, so and so. Um, if we look into modules, it'll teach us uh, how to create modules, how to work with modules, basically how to what's the word? Visibility, how to control visibility, how to divide up your code into different sections. So I could go through this as well. I mean, technically, you probably should be going through both of them side by side, not one or the other. But yeah, I could do this. I could just like quickly go through all of this. In the past, I decided to pause on this because it's a whole lot of information, and I liked the way that Gemini was giving me the information. So I stuck with Gemini. I'll see. I'll see. Because you also have something like smart pointers, which there's a lot of information under smart pointers because there are different types of smart pointers. Okay, fearless concurrency. Here we're going to be looking into, I believe, both async and multi-threading. I'm not sure though. Okay, async comes in later on. Okay, object-oriented programming features. Okay, all right. Then pattern matching, advanced features, unsafe Rust, advanced traits, types, so and so. Right. Okay. Wait, where is FFI? I haven't seen FFI mentioned here. FFI was definitely part of where is is that like its own separate thing? That might be its own separate thing. But yeah, that's also one of the things that gets covered. So is macros. Macros was also something. Oh, macros is mentioned here. Could it be under advanced functions? Wait, I didn't know function pointers was a thing here. I think it. Okay, maybe I did know it because it's one of those things where you can like assign a function to a variable. I can't remember. I haven't done that nearly as often in Rust to remember that that's that's a thing. Yeah. Okay. You know what? Um, yeah, I have some thinking to do about whether I wanna, because I need to get back into Rust and all of the stuff that I'm doing. Like I'm later on, I'm going to be learning more Rust stuff and doing more Rust projects. So eventually, I will have to learn the extra stuff that I haven't learned yet. So I might as well learn it right now, bit by bit, if that makes sense. Currently, I'm on iterators. I've finished closures. I could either get Gemini to generate the rest of that. The thing is, I haven't touched Gemini CLI in a while now. After it started having those weird bugs, I stopped using it a whole lot. The weird bugs of like, it constantly kept saying that, oh, you've used your daily quota when I hadn't touched it in like a month. And it's still saying, oh, you've used your daily quota. So after I started having those kinds of issues, I stopped using it. And a couple of months later, I think, I updated Gemini CLI, and it had a bunch of new features. And I believe the bugs were also fixed at that point. It had a bunch of very interesting, very useful features, but I just wasn't using Gemini CLI nearly as much at the time. Um, so now I don't know if I want to continue from there. But like, dude, that syllabus that was made, that was nice. That was great. That being said, just because, I started with that, I don't have to finish with it. In fact, I didn't even start with that. I had started learning the basics from the book, and then I moved to Gemini CLI to get like a more concise version. And now I think I can move back to the book. But instead of having to read through all of the, very long text here, this is not a good example of long text, but like they have long text in various sections, like let's say, I don't know, maybe smart pointers, right? There's a lot of stuff to look at. There's good reason why there's a lot of text here. It's just that at the time it was a little annoying for me that there's so much text that I'm reading and things are going kind of slow. What I could do now is just jump over the text. I'll skim through the chapters quickly. And then if I ever need more information, then I can come back and look at that information, or I can just ask Gemini, and Gemini will give me those bits of information that are missing. I feel like this is one part of the studying that I somehow it didn't occur to me. This one technique where if the text is way too long, then just skip it, just jump over, different sections, different topics, skim through it very quickly, and if there's any doubts, then you can always ask Gemini. This is Rust. Gemini knows a lot about Rust, so I'll be able to get whatever information I want regarding Rust, at least. But yeah, dude. Um, okay, so I think that's going to be it for today's stream. We have streamed now. In the next 20 seconds, it'll be 1.5 hour, so, or 1.5 hours. I'm not sure if there's supposed to be an S there. Either way, um, that's great. We were doing one of our more quieter streams today, and I managed to stream for our regular amount of time, our regular, length that we usually stream, hour and a half. So I'm happy about that. I do need to rename today's stream to talking about my terminal based, no, let's say pondering ideas for terminal based VTubing. This is going to be super clickbaity, but whatever. Okay. Yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time.